cover why we don't have a solution. But what I do want to talk about today real quick is when we have two solutions, because you will have one of these on your test, okay? And we'll go over one of those no solutions later. But when we are going on our test, now when we talked about our homework quiz, we had something that looked like this. Cosine of theta equaled 1/2, right? And fortunately for us, that problem only said the constraints were between 0 and pi over 2, right? Yes? So all we had to do was find the angle between 0 and pi over 2, where cosine equaled to 1/2, which we said was at this angle, square root of 3 over 2. So therefore, remember, guys, when you have a cosine of an angle and you have a value, right, in your calculator on this problem you guys just did, that's a decimal, right? But in this case, you know the angle we said was pi over 3, or 60 degrees, right? However, is that actually, you know what am I doing? I don't want to do sine. Let's do sine instead of cosine. So when is sine of theta equal to 1/2? Well, we know that that is over here, right? And that's not at pi over 3, it's pi over 6. Okay, sorry, we want to deal with sines for this because we're doing the law of sines, not the law of cosines. So does everybody agree that the sine of your angle, when it equals 1/2, is pi over 6? Does everybody agree? But if we look at the whole, now your homework quiz only said between 0 and pi halves. But if I look at the whole unit circle, is that the only place where sine equals 1/2? No. Does anybody remember the other angle where it equals 1/2? Anybody want to blurt it out or raise their hand? 5 pi over 6. It's a direct reflection from here. Okay? At 5 pi over 6, it's negative square root of 3 over 2, comma 1/2 on the unit circle. But you guys see for both of those angles that sine is equal to 1/2, right? So when you're taking the inverse, because that's exactly what we're doing. If I say the sine of theta equals 1/2, and I want to know what is theta, theta equals sine inverse of 1/2, which in our case is going to be pi over 6, or 60 degrees. Plug that into your calculator. Inverse sine of 1/2. It's going to give you 60 degrees if you're in degree form, degree mode. All right? So there's an issue now we have. If we take the inverse of sine, there's two possible angles, right? Because if I take the inverse sine of 1/2, I could get pi over 6, 60 degrees. Watch this. Take what? Well, you already know. Take the sine of 5 pi over 6 and take the sine of 1/2. I'm sorry, not 5 pi over 6, of pi over 6. Plug those two in your calculator, and you're going to get 1/2, right? So that means when I'm taking the inverse, which angle am I going to be dealing with? Should I be dealing with pi over 6 or 5 pi over 6? Which answer am I actually going to use? Because there's actually two angles where sine equals 1/2. So we have an issue, right? So what our problem is, and I'm actually going to convert these to degrees. Angle would be 30 degrees, or this angle would be 150 degrees. And the way that I can get them is take 180 minus 30 degrees equals 150. That's how I got 150 degrees. I subtract my angle from 180. All right? So the issue that I want to bring to you guys is, why is there a possibility for us to have two cases? Because, ladies and gentlemen, anytime you have one acute angle, you are now going to be finding the other angle, one of the other angles, right? And remember, when you find an angle by using the inverse sine, there's two angles. There's the acute angle and the obtuse angle. Well, you've got to make sure you can check both solutions, because the acute angle and the obtuse angle, or this obtuse angle and this angle, could still be under 180. All right? If it's greater than 180, then obviously there's only one case. But I'll go over this example for you guys. And actually, I won't make it